So in section 3, we're going to take a look at confidence intervals for population mean. So in section 2, we looked at finding confidence intervals for a proportion using a z critical number and the sampling distribution for our sample proportion. And we can use a similar process for a sample mean, but there's one very important difference. So first we're going to review the criteria for a sampling distribution. So the shape is going to be normal, and we can assume that the sample mean is normal if the size of the samples is 30 or more. If it's less than 30, you have to check it in another way. The center, so the mean of our sampling distribution, is the same as the population mean. And for the spread, so as n gets larger, the standard deviation of our sampling distribution gets smaller. So just to review our formulas, the mean of our sampling distribution equals the mean of the population, and the standard deviation of our sampling distribution is equal to the population standard deviation divided by the square root of n. And again, the key component is that it's normal, and we use the fact that the sample size is greater than or equal to 30. So we can do the confidence interval in the similar way to the proportion, but only if we know the population standard deviation, which we will not know in most cases. We'll only know the sample standard deviation. So that's where the difference is. So there's two different ways to calculate the confidence interval for a sample mean. The first is with a known population standard deviation, and the second is with an unknown. So if we know the population standard deviation, then we choose an SRS of size n with our known population standard deviation, and as long as it's normal and independent, the confidence interval is given by the formula x bar plus or minus the z critical value times the standard deviation of the population divided by the square root of n. So we basically just took the same formula we talked about in 8.1 and just replaced the mean with the x bar and the standard deviation with the formula for means. So we're going to take a look at an example. So a sample of 45 new teachers found their average first-year salary to be $35,675. If the population standard deviation for new teacher salaries is known to be 2,548, find the 90% confidence interval for new teacher salaries and explain what this interval represents. So because we know the population standard deviation, we can use our formula x bar plus or minus our critical value times the standard deviation divided by the square root of n. So the x bar is going to be the 35,675 plus or minus. So we want to use our table to find the critical value for 90% confident, which is 1.645. And then times the population standard deviation, 2548, divided by the square root of n, which is 45. So we'll have 35,675 plus or minus. Then I'm going to do this all in one step in the calculator. Okay, and then we have 624.83. I'm only going to round 2 decimal places here because we are talking about salary, which is a number, and we only round numbers to 2 decimal places. So we're going to do 35,675 minus 624.83. And our lower value is 35,050.17. And then we'll do 35,675 plus 624.83. And we'll get 36,299.83. So when we are explaining what this interval represents, it starts off very similar to when we were doing it for proportions. So with 90% confidence, the average of all teacher salaries is between 35,050.17 and 36,299.83. So it's very similar to what we did for proportions. We just used different values and a different standard deviation formula. However, we will rarely know the population standard deviation. So we don't know that. We still have to calculate confidence intervals, but we'll have to use a different type of distribution. So instead of having a Z critical value, we have something called a T critical value. We use something called a T distribution. Okay. So a T distribution is a type of normal distribution based on the sample size. Okay, so if we're looking at our curves, our Z curve is based on the population, but the T curve is based on the sample. So it's not going to look like the same normal curve. It might be a little bit below because the sample is typically smaller than the population. Okay, so we use the T distribution to find any confidence interval where the population standard deviation is unknown. So we replace the T for the Z critical value. The sample must still come from a normally distributed population, so N still has to be larger than 30, or you have to check for it being normal a different way. So when we don't know the population standard deviation, the confidence interval is calculated a little bit differently. So we still choose an SRS of size N. We still have our unknown population standard deviation, and as long as it's normal and independent, we instead use the formula X bar plus or minus our T critical value times the sample standard deviation divided by the square root of N. So T is the critical value from our T distribution, and we have to do something called degrees of freedom. So the way that the T score is calculated, so this is where the rest of the table is going to come into play. So we have to look at N minus 1 to help us with our confidence interval. So we have to do something called degrees of freedom for it. Okay. And we'll talk about this more in the second part of the video and how that plays into a part with calculating our confidence intervals.